Good evening, class. Today we'll discuss about the miscellaneous problems of integration. You have already studied about various forms, type-wise, by parts, partial. Now in miscellaneous we discuss the problems which are not particularly related to any form directly, but can be converted after simplification or substitution. And they don't have any form directly, and it's not that easy. It's only with a practice this comes, and a command over differentiation along with command over trigonometry. So we'll discuss today some types of problems related to trigonometry and how to solve them, and even in some questions we'll be discussing about various methods just to give you an idea how to crack the problem. Particularly at times you are not able to crack a problem because the method doesn't strike. So once we deal various types of alternatives, then it gives you a better chance to solve a problem whenever you get across a new problem, right? So I'll begin with some of the questions which are there in miscellaneous. Now this is a very important problem, as it will come later on in definite also, and as well as indefinite. Right now we are dealing with indefinite. So this is one problem I'd like to discuss first. Now sin 2x upon sin 4x plus cos 4x. Now the first thing which we see is 2 sin x cos x. This can be written as, and once you put cos x equal to t, obviously sin x goes. But in past we have seen in integration that sin 2x is derivative of sin square x as well as cos square x. So here, as a one way we can use sin 2x dx, and you can observe that we have a square of sin square x as well as cos square x. Now going and simplifying this way, it suggests that we can easily put sin square or cos square as derivative. Obviously we cannot take both as derivative because you have power involved here. So you cannot do that as we did when there was just simply sin square x plus cos square x here. So here you can take any one as t. So let us take sin square x equal to t, and the benefit you can see is we have cos square x, which is again convertible to sin square x. So this problem can be solved easily now. Now what would be the derivative? 2 sin x cos x equal to dt by dx. 2 sin x cos x is equal to dt by dx. Now we know that 2 sin x cos x is nothing but sin 2x. So once you do this, so sin 2x dx is equivalent to dt. So our I would be equivalent to what? Instead of this, you can substitute dt. Here you have sin square x. We'll do substitution once we get everything in terms of sin. And here you have 1 minus sin square x whole square. So now we have put not sin x, sin square x equal to t. So what would we get after this? After this, our I would basically reduce to dt upon t square plus 1 minus t, sin square x is t, so t square whole square. Now you know that this can be very easily integrated using perfect square. Dt upon t square plus 1 plus t square minus 2t. And let me tell you, this is, we are discussing method 1, right? I'll be discussing 3 methods for this problem, just to give you an insight like how you can attempt this problem. Once you get couple of methods, you get a better view. Maybe some methods may be applicable for other problems and some may be easy here. So we'll be discussing quite alternative ways of doing it, and then you will be able to crack some problems in a much better way without the help of anyone. And now t square, so 2t square minus 2t plus 1 by 2, t square minus t plus half, which is half dt upon what? T square minus t, and to make perfect square we divide by coefficient of t, half of that, and add the square. So t is half, coefficient is 1, half, so you add half ka square and you subtract half ka square. So what you will get, half dt upon t minus half whole square plus 1 by 2 minus 1 by 4 plus 1 by 2 minus 1 by 4. So this can be now written as dt upon t minus half whole square, and this would simplify once you take LCM. So this would be 4. So 2 minus, I suppose 1, that's 4. So 1 by 4. So now this can be written as t minus half square, and after simplifying we would be getting what, 1 by 4 over here, that can be written as half square. And now this is in the standard form, dt upon what, x square plus a square. So the formula for that is 1 by a tan inverse x by a. So that is t minus half over a. So 1 by a. So 2 tan inverse 2t minus 1 by 2 upon half plus c. So this gets cancelled and we would finally arrive at an answer 2 tan inverse. So what was t? Tan square x minus 1 plus c. Now this was method 1 which we discussed, and you could get this problem, and the suggestion was sin 2x sin square. Now suppose we go for some other method. So right from here we go for some other method to solve this problem. How do we go about it, right? Now you can see that sin square x plus cos square x. Now there is something you have studied, that a squared plus b squared is a plus b whole square minus 2a. Even in class 10 we keep on simplifying this expression, sin 4x plus cos 4x. Now let's see how we can use this to our convenience for solving the problem. Okay, there's just one dx out here, sorry. Now a squared plus b squared. So a is sin square x, and what is b? Cos square x. So a plus b, what? Whole squared minus 2ab. So what is our a? Our a is sin square x. So 2 sin square x and what? Cos square x, right? Okay. Now sin 2x 1 minus 2 sin square x cos square x dx. Now after this, how do we go about again? Now say alternatively if I put sin square x equal to t, so sin 2x is dt, and again t into 1 minus t. But again it would reduce to same different form, so nothing much different we are doing. Now is there any other alternative which we can go about after here? See, you have to keep looking at this numerator. We have a sin 2x. So sin 2x is derivative of sin square x, 1, and it is also derivative of cos 2x. Now can we get cos 2x over here somehow? Yes, we can get. See, 2 sin square x can be written as 1 minus cos 2x, and even cos square x can be written as 1 plus cos 2x. So once you write that and you have that as a derivative, so straight away you can do what? Sin 2x upon 1 minus 2. I am putting this formula of what? 1 minus cos 2x by 2 and 1 plus cos 2x by 2 and a dx. So now you can see that, let's cancel this, but cos 2x is derivative of directly sin 2x, right? So if I put cos 2x equal to t, I'll get sin 2x into 2 is equal to dt by dx. So you can cross multiply, you will get sin 2x dx is equal to 2 dt. Sin 2x dx is equal to dt by 2, sorry, not dt by 2. So now what would I be? I would be dt, okay, by 2, and you will have what? 2 minus 1 minus t into 1 plus t divided by 2. So instead of cos 2x you can substitute t over here, so 1 minus t into 1 plus t, and when we take this LCM, this 2 is get cancelled, this 2 would come over here, and this. So ultimately this also gets reduced and it gets cancelled. So what we are left with, I is equal to dt upon 2 minus 1 minus t square, that is what, 1 plus. So compared to previous problem, you can see that it's a shorter one which is easily integrable, and I is nothing but what, tan inverse t plus c, and that is what, tan inverse, what was t? T was cos 2x plus c. And you'll see different methods gives you different problems, answers. In integration, depending on the methods which you apply, you get the answer. And especially in trigonometric functions, since there are a lot of simplification involved, you can definitely get different answers. Last time we had something in terms of sine square x, but cos 2x can also be written as 2 sine square x minus 1 and so on. So that can be done. So now you see this is an alternative way. We started off in a different way, and obviously I feel that we have lesser steps in this problem compared to the previous method. So this is one more way of doing this problem, and where will this help? The next problem which I'll come, definitely you will be able to do. So this was method 2. So this is the method 2 of solving this problem, where we started off and then we changed the method little bit. Now we'll go to after this one more method, which is the shortest method for this particular problem. So we'll discuss that method 3. Commonly you'll find that the method is being given in the books, but just for your knowledge, I've discussed this steps. Now we'll discuss method 3, which is the shortest method for solving this particular problem. And as you know why we discussed other methods, just to give you an insight or view what we. Now I'm going to write it as 2 sin x cos x, and then you have sin 4x plus cos 4x here. Now had there been square, this would have been a very simple problem, and you can see that putting sin x or cos x equal to t will be a little cumbersome out here, and we have tried other method. Now one more, the method which works with the problems of trigonometric function is division by cos and sin. So now dividing by highest power of cos, which is 4, cos to the power 4x, what do we get? I? We get I as 2 sin x cos x upon cos to the power 4x, and similarly sin 4x cos 4x upon cos to the power 4x. Now how does this help? Let's see what benefit do we get. Now you can see that one cos gets cancelled, so 2 sin x upon cos cube x, which I am writing like this. Why I am writing like this? Now you know that whenever we divide with such type with cos or something, we get tan usually in the denominator, and then we should have sec square so that we can put tan t. So for that particular reason, one cos gets cancelled. I know there will be cos cube, and that has to be split in such a way we get a cos square, so that we get sec square, and in denominator you can see you have tan to the power 4x and plus 1. So now you can see we have tan in the denominator and we have sec square in the numerator. So which again suggests by a method that we'll put what? Tan x co t. But let's watch a little further. This would be 2 tan x, right, into sec square x dx upon tan to the power 4x plus 1. Now from here I have two alternatives. One is the simple alternative, which by my practice I can see that we have solved so many problems. You just put tan x co t, you get sec square dx dt. So what you would get? 2t upon t4 plus 1. 2t upon t4 plus 1. Now 2t upon t4 plus 1, you know 2t will be derivative of t square. So what you will have to do, again substitute t square equal to u and go ahead. But if you observe it properly, one problem, see tan x has a single power and then sec. So if you can put tan square x equal to t, What is the derivative? 2 tan x, but then we'll have to differentiate tan x because this is chain rule form, u form. So you'll get sec square x dx equal to dt. Now you can see the entire derivative is there. And what is the advantage? We don't have to put any more substitution, dt. And you have tan 4 here, which is what? Tan squares whole square. So tan 4x is square of this. So you have t. What would come over here? You'd get t square plus 1, which is nothing but tan inverse what? T plus c. So that is tan inverse tan square x plus c. So this is the shortest way of solving this particular problem, which is a very important problem from examination point of view. And this gives, see, you have to again see here that power 4, 1 less and then. So maybe if it is square over here, so it's square over here. So then there should have been 6 over here. Why? Because then you get 2 tan square x into sec square. So if it is tan raised to power 6x over here, then in such, for example, something like this, 2 tan square x sec square x. So this substitution would work. See particularly. Now in such type of problem you can correlate. You can put tan cube x t. So once you have tan cube x t, you'll have 3 tan square x sec square x dx and so on. So you have to develop this concept and then such problems can be easily solved. So that is what it comes with practice. Halt. In the previous question, I discussed 3 different ways of solving a problem, and why I discussed it, you will be seeing it right now. Now, if you compare the particular problem I am going to deal with this last one, you will find little difference. Say integration, even a single change can change the course of the problem entirely. Now, see, I don't have sine 2x in the numerator, I just have this. Suppose this is the problem now. So last time the third method, we had advantage, we could divide and get. Now here we'll see dividing also will help, but particularly the methods which we used last time, how will they work? Now first I'd like to use sine square x whole square plus cos square x whole square. Right. Now as I said, we simplified it. A square plus b square, okay, a square plus b square upon that. Now you can do that over here, same way I am doing it. So you can do sine square x plus cos square x, what, whole squared minus 2 sine square x cos square x. That's a simple problem. Now dx upon 1 minus 2 sine square x cos square x. Now from here you have various alternatives of doing this particular problem. My method, why I suggested that, now if you can convert this to cos, very simply the problem will be solved, or even you can write this as sine square 2x by 2. So you know 2 sine x cos x, sorry, 2 sine x cos x is sine 2x. So you can singly get sine square 2x also, or you can convert both to cos 2x and go ahead. So maybe I want to convert to sine 2x directly. So 1 minus, we can introduce 4 sine square x. Now why we have done that? You could have done one directly, but this is what? Sine 2x whole square. Why it is sine 2x whole square? Now you can see that I is equal to dx upon 2 minus 2 sine x cos x whole squared upon 2. That is 2 upon 2 minus sine square 2x. Why sine square 2x? 2 sine x cos x is what? Sine 2x. So you'll have sine square 2x. Now what is the thing we will do after this? Now this reduces to a very well known form. Which one? Dx upon is a sine square x plus b. So now there is no difficulty, we just need to divide by cos square of what? Whichever angle it is. So if it is sin x, cos square x 2x, we'll divide it by cos square 2x. So 2 is out, 1 by cos square 2x upon 2 minus sin square 2x by cos square 2x, obviously dx. Now you know it's very easy to solve. It becomes what? Sec square 2x, 2 upon cos square is sec square 2x minus tan square 2x. Now sec square is derivative of tan, so entire denominator needs to be converted in terms of what? Yes, tan square x. So once we have that, this problem can be solved again very easily. 1 plus tan square 2x minus tan square 2x. So now just you need to put tan 2x equal to t. So once you put tan 2x equal to t, what will you get? 2 sec square 2x dx equal to dt. So my I would become what? dt upon 2 into 1 plus t square minus t square. So that is 2 plus 2t square minus t square. Right? I suppose we are going right. Yeah. 2 into 1 plus t square minus t square. So this particularly would be what? dt upon t square plus root 2 whole square. Why root 2 whole square? Root 2 square. So 1 by a tan inverse t by root 2 plus c. And what was t? T was nothing but just tan 2x. So tan inverse tan 2x by root 2 plus c. So that is how we can solve this particular problem. We'll discuss, just saw the solution of this problem. We'll also give you alternative, which is a common solution in most of the books, as we did for particular problem in the previous one, dividing by cos to the power 4x. So you'll get 1 upon cos to the power 4x dx and sin to the power 4x plus cos to the power 4x upon cos to the power 4x. So what would this lead to? This would lead to our I equal to sec to the power 4x tan to the power 4x plus 1 dx. Now last time we could solve it much easily because we had 2 tan x and sec square x. Now the situation is changed. So that's why I was discussing alternatives by which it's not necessary we follow pattern. Now here what is the method? You just have to put tan x ko t. So you'll get sec square x dx equal to dt. Now how do we break the numerator? Numerator 1 sec square x would get absorbed by substitution and other can be substituted back in terms of tan. So this is the situation right now where sec square x dx, you can see from here, would be dt, and this particularly 1 plus tan square x upon tan raised to power 4x plus 1 and sec square x dx. So now tan x is what? T. So what do we get? 1 plus t square and 1 plus t to the power 4 dt. And this is a very standard problem. If you remember, it's based on the special integral where we divide such type of problems by t square. So dividing by t square, so we'll get 1 by t square plus 1 upon 1 by t square plus t square. And you know that how do we express this? A squared plus b squared 1 by t minus 1 minus 1 by t, right, square. So now why did we use t minus 1 by t square? Because you see we have 1 plus 1 by t square. Had we got 1 minus, then we would have taken t plus 1 by t. So t minus. So what is the extra thing which we are getting? you can see that t square plus 1 by t square, it's okay, but when you expand it, you will get minus 2t into 1 by t. So minus 2t is extra, so plus 2, or otherwise a square plus b square, a minus b whole square plus 2ab, or a plus b square minus 2ab. So 2t into 1 by t, that gets cancelled. So your I is 1 by t square plus 1 dt, and denominator is t minus 1 by t square plus 2. So this is a common method, it reduces. Then from here, t minus 1 by t can be put as z, or u, whatever you want. Dt is equal to dz, 1 minus 1 by t square. So I would become what? Dz upon z square plus 2. That is dz upon z square plus root 2 whole square. So I is equal to 1 by root 2 tan inverse z by root 2 plus c. So 1 by root 2 tan inverse, what is z? So t minus 1 by t was z, 1 plus 1 by t square dt, it became dz. So this was substituted as what dz, this becomes z square plus 2 as it is, and then we applied the formula x square plus a square is 1 by a, tan inverse x by a, and finally what was your t, as it was tan x. So 1 by root 2 tan inverse tan x minus 1 by tan x plus c and whole divided by root 2, which you can write. So that is a way of doing this problem, right? So you have seen that we can discuss a problem in various ways. So that is what miscellaneous is further all about, applying all what you have learned and then going by the best method, right? See the problem. Now I'll give you a very shortcut method, not very commonly found in books, but this is by experience you can also do. Now see, you would have come across this particular question at a very initial stage of integration, dx upon. Various ways of doing it, out of which one of the common is you write this as 1 and you break this as what? Sin square x plus cos square x, and you write it sin square x cos square x dx. And once you separate this, what do you get? So this has helped. This technique is getting denominator as a single term and numerator as sum or difference. That's why this method works. You have divided it. So you can see that sec squared x and plus cosecant squared x, that is, which is again a very easy way to do. Now the same technique can be applied even to further problems. Just by practice and experience you get to know this. Right, this is simply done tan x minus cot x. Now using this technique I'll solve the particular question which we did before in a different way, and the method which we did is again different, not followed in books. Usually they divide by cos x and then go to the traditional method of dividing by t square, which is a little lengthy one. I'll give you a shortcut for this particular problem. So the problem is dx upon sin 6x plus cos 6x. Now what is the shortcut we have? Now see, in the previous just example I showed you that if you have sin square x cos square x and you write it as 1, it becomes this. Now in this particular problem, what advantage do we have? I'll show you. Here we have 1, so I am writing it as 1 cube, which is very well which is something which we can easily do with 1. It can be 4 or 2 or whatever. Now to our convenience, and in trigonometry we know that 1 is what? Sin squared x plus cos squared x. So this becomes this. Now what is the advantage we'll get? You just note 1 has been written as sin square x plus cos square x, and why I have used cube? So that I can get 6. Now you expand it, a plus b cube. A plus b cube is what? A cube plus b cube. A plus b. Now if I use this particular formula, what is a? Sine square x, so I'll get sine to the power 6x plus cos to the power 6x plus 3 sine square x cos square x into sine square x plus cos square x dx. Now you can observe that this becomes 1, and when we separate, you can see this term would get cancelled very easily, and one integral can be easily solved. So I am separating this, sine to the power 6x plus cos to the power 6x upon sine to the power 6x. So the 6 is eliminated here, and 3 sine square x cos square x left with upon this. Why I am not writing this part? Because this is 1. So sine raised to 6x. So now this integral we can cancel, so you are just left with dx. Now how do we integrate the second part? Now this is an interesting one. Now if you correlate, now that's what I said, it comes with practice. Some of you may not be finding it a familiar form, I'll just show you. When we integrated something like this, something like this. Now you see the power was something 4 out here, and we divided it cos 4x, and what did we get? Tan x sec square x. Now with this we have, I'm just taking this part that is already integrated x, 3 sine square x cos square x. Now see the correlation between two problems. I'm dividing it by cos to the power 6x. So 3 sine square x cos square x upon cos to the power 6x plus cos to the power 6x upon cos to the power 6x. Now what is the advantage we get? If you see that, obviously one would get cancelled, but can I write upon cos square x into 1 by cos square x? See what I've done. Cos square x and cos 6x, once you cancel, what you will get? Cos 4x, right? Out of which I have to make sec square because I am getting tan out here, as I did in this problem. If you go to the solution of this problem and see, that is what we have, we'll get tan and sec square x. So this portion cos square x gets cancelled, 4, which we have distributed, and here obviously you'll have tan to the power 6x plus 1. So what do you get? 3 tan square x sec square x plus 1. Now if you observe in that particular problem, in this particular problem we got 2 tan x sec square x, and there was tan to the power 4 out here. What did you substitute? Tan square x. You got this. Same thing you can do here now. Just put tan cube x equal to t. You will have this entire thing gone, and the problem can be solved much easier way. So after that step, we just have to do one more step, and that's the observation. After this step, what I am doing it is put tan cube x equal to t. So once you put tan cube x equal to t, what you will get? 3 tan square x, and then derivative of that is sec square x dx is equal to dt. So it would become dt and tan 6, so it's the square of this. So you don't have to do anything, you just get very easily tan inverse tan cube x plus c. So see how alternatives have helped us, and usually you will not find this solution commonly in books and other ways, because the common solution given is dividing by cos. It's just by practice and sheer observation you can correlate things and go ahead. So integration is a very different type of topic where your practice can give you or make you learn so many new ways of doing it. So that is the fun with integration. Once you get used to it, you just need to observe and start playing with it. So now you can see that we have arrived, just a correlation with this two. I'm just correlating, this part has nothing to do, I'm just correlating the problem, and here we can get it, right? And before that you just add x, so x was there, x plus tan inverse tan cube x plus c, right? Okay. Now we'll discuss another type of problem, which is again a very common and important problem and part of integration. This problem, which is very commonly asked in exam, and it's an important form of a miscellaneous question where this problem comes. Sine cube into sine x plus alpha, where alpha is a constant. Now this problem has a combination of sine and cos. You can have cos cube here, you can have sine here, cos here. So these two getting interchanged, and the method remains the same for all the problems. Now see, the problem here is we have a cube out here. So due to that you cannot proceed ahead and go. Now to take out of the root, either they should be square or they should be power 4. Yes, you can take sine square, then the sine goes common and you have sine x plus alpha and sine x plus alpha, which you can expand and go ahead. So you have one sine out. So, but one sine is not again going to solve the problem. So what I'll try to do over here is, we have sine cube, I'll try to get a sine 4 so that this term entirely goes out. I don't have anything left. Now how do I do that? I'll keep as it is, nothing can be done over here. But we can expand this. Which one? Sine a plus b, sine x cos alpha plus cos x sine alpha. Now why we are trying for sine to the power 4x is, one is this term goes out, and it goes out and becomes cos x square x. See, sec square x, cos x square x, these are the two forms where the substitution tan x and cot x is coming into picture. So in this problem, that is what the approach we are trying. Now you can see that I am taking sine common, then only this will become sine to the power 4x. Once you take sine common, you are left with cos alpha and then cot x sine alpha. Why cot x? Because there is no sine over here. So if we are taking out, we'll have to divide this. This is it. So 1 upon this. So what we are left with? 1 upon sine square x cos alpha plus cot x sine alpha. Right? Now what do we get? We'll get our I is equivalent to what? Cos x square x dx, right? Cos x square x dx, now which is derivative of cot, and you can see that we have cot over here, and that is cos alpha plus cot x sine alpha. After this, what I have found that most of the students get stuck, or they use the substitution simply cot x equal to t. So let me ask you one thing, like if the question is cos x square x is equal to say 2 plus 3 cot x, then what would be the substitution? In then similar situation, most of the students would reply that we will put 2 plus 3 cot x equal to t square. Why? One is 2 is a constant, it merges in the derivative. To remove the root, if you put t square, it becomes easy. Now if you compare the situation, this is also a constant, this is also a constant. So what is the difference in these two situations, except that this is not a familiar form? That is what confuses students in putting it directly. Otherwise, the work becomes again little lengthy. So what I can do now is similarly cos alpha plus cot x sine alpha. I'll put it equal to t square. Same format. So what is the derivative of cos alpha? 0, because it's a constant. Cot x minus cos x square x sine alpha 2t dt by dx. So now cos x square x dx is equal to minus 2t dt by sine alpha. So now our I becomes what? Minus 2t dt upon sine alpha, and here we have root t square, which should cancel this. So that is minus 2 cosec alpha t by t, that is simply dt. So this becomes 2 cosec alpha into t plus c, which is nothing. What? T is just under root of this, so minus 2 cosec alpha under the root cos alpha plus cot x sine alpha plus c. So that is how this problem can be solved. And comparing to this problem, now you see This is a particular problem which is given. It can be other problems also. See, if you have x over here, you will have x over here, maybe 2x, then you may have 2x over here, and so on. Now there are so many other type of problems based on this particular problem. Now you can practice one question I can write like this. It can be sine cube x cos x plus alpha, or you can also have a question where you have cos cube x, say sine x minus alpha plus alpha doesn't make it. So there can be so many questions which can be created on this particular form. So all these problems are based on this form. There can be a number of questions which you can have, and the cos. So obviously when the cos is here, it will come out, it will become sec square, then we would have tan x substitution. So this is one of the important problems. Just a single problem is given, but based on this so many can be created. And after this we will be looking into one more problem based on this, which is little more typical compared to this. Okay, now look at this problem. We just discussed sine cube x in the denominator and so on. So we have something called sec x out here and sine 2x plus alpha plus sine alpha, where alpha is again a constant. Now how do we approach this problem? Say in miscellaneous you will not find sometimes at least a clue by looking at the question, you just go blank. So looking at this problem, it's not a very familiar form which you can just see and crack it. And always go for cos, sine, that is one substitution, and sec square and something. We don't have sec square, we have just sec out here. Now let us try to simplify and go some further steps. See, this cos x has come outside. Last time you saw we could take sine square outside or cos square, but we have cos x outside. Now what do we do here? Because last time they were in the multiplied form and you had something, so there were no product. Now do you think, can we apply some formula? Yeah, sin a plus sin b. What is sin a plus sin b? 2 sin, yes, a plus b by 2, correct? And what? 2 sin a plus b by 2 into what? Cos a minus b by 2. Now how does this help? Now one thing which I have is, compared to previous problem, I get a product form here. Now how does that help? You have dx cos x. What do you get here? 2 sin 2x plus 2 alpha by 2, you have this, into cos 2x by 2. So this would reduce to dx upon cos x, a root inside. See, constants never matter, so 2 sin and x plus alpha, 2, they all get cancelled. 2 can be taken out and cancelled with this, and you have cos x over here. Now, after this stage, what you can do? See, if you closely observe the previous problem, there was sin x plus alpha and sin cube x here. I said either you can have cos square out or sin cos out. Now see, there was no cos x out here. This particular term was not there in the previous problem. Instead, what did you have? You had a cos cube inside, and then you made 4 come. That means if this cos is outside, if I take it inside, what will this become? This will become cos cube x. And if this becomes cos cube x, it is same as the previous question. So how examiner is trying to fool you or confuse you, instead of this giving a cos cube inside, is just taken one cos outside and given you. So now this problem is same as before. Now you can very easily see that this problem can be solved very easily. Let the cos be there. I'll apply the same method, see cos x. So 2, even you can take this root 2 common. So that goes out, sin x plus alpha. So sin x cos alpha plus cos x sin alpha into cos x. Now you can see that we just need to take cos common so that it goes out. So 1 by root 2 dx upon cos x, and from here you have to take cos common, so it becomes cos square. I am writing this before, so cos square x. So what is left here? If you take cos common, there is no cos x out here, you'll have to divide by cos. So when we divide, what we will get? Tan x cos alpha plus sin alpha. Now you see the particular problem. So in integration, sometimes we have to guess a particular problem. Is this one and the same thing? What examiners do is just try to confuse you and see how good your grip is. And in this particular case, this comes out, becomes cos square x, cos x comes out, so root of cos square x, and then you have tan x cos alpha plus sin alpha dx. So 1 by root 2, what you have now? Sec square x, and last time we had cosec square x, so tan x cos alpha plus sin alpha. Right? Now this can be easily integrated. You don't have to do much for that. It's the same thing. Tan x cos alpha plus sin alpha equal to t square. So you'll have sec square x cos alpha 2t dt by dx. So what you will get? Sec square x dx. So we put this equal to t square. Derivative of tan x is sec square x. Cos alpha is a constant, and purely constant 0 is the derivative, and 2t dt by dx. So we cross multiply 2t by cos alpha dt. So what is our I? It would become 1 by root 2. So we are getting this term. So instead of sec square x dx, you can compare what you will get. 2t by cos alpha, right, dt upon root of t square. Sorry, root of t square. So 2 by root 2 sec alpha t by t dt. So 2 by root 2 simply is root 2 sec alpha into t plus c, which is nothing but, what is t? Yes, under the root tan x cos alpha plus sin alpha plus c. So you could see that same problem was asked in a different way, and that is what we call as miscellaneous. That misleads you basically, and then it's not that easy to catch the form. So in integration, you have to identify the forms, practice, and then you have to correlate, right? So this was a solution for this. Now we'll discuss one more important type of problem related to sine and cos, very commonly asked in exams. Now I'm discussing a problem. So this is based on the form sine raised to some mx and cos raised to some nx in the denominator. Now how do you solve this type of problems when they come here? The concept is you take the LCM of the powers and then you substitute or divide by cos to the power or sine to the power. So here if you see root, so it is 3 by 2 and it is 5 by 2. So 3 by 2 plus 5 by 2, 8 by 2, that is 4. So this particular problem will be solved by dividing by cos to the power 4x. Had there been no root, then 3 plus 5 is 8, we would have divided by cos to the power 8x. Now due to the square root coming here, we are dividing it by 4. So 1 upon cos to the power 4x, that is I, upon root sine cube x cos 5x upon cos to the power 4x dx. Now what advantage this division gives? See, all thing that was making this problem complicated was denominator. It was not so easy, it was seeing. Now how do we go about it? Now we can see once we divide, you'll get sec 4x. Now which very easily suggesting you that has to be tan in the denominator, right? So how do we make it? So see, the power is 8 over here. Once we take cos 4 inside, what will happen? From root, if you take out x square common, what do you get? X. So if you take x inside root, what you will take? X square. So if you take cos 4x inside it, what you will do? What will the power become? The power would become cos to the power 8x. So this would get cancelled. I am breaking it as what? sec square x into what? Sec square x. And this gets cancelled and you're left with tan cube x. So now you know the derivative of tan is what? T square. You can put tan cube x equal to t square, or you can put simply tan x equal to t square. So tan x is equal to t sec square x, sorry, tan x equal to not t square, t sin sec square x dx would become dt. So your I would become 1 plus tan square x sec square x dx. So this would be nothing but 1 plus t square dt upon t to the power 3 by 2. How 3 by 2? If you put t over here, you get t cube. So that is t to the power 3 by 2. And I would become what? 1 upon 3 to the power 2 plus t square upon 3 to the power 2 dt. Now both of them can be very easily integrated. And here you would have 2 minus 3 by 2 dt. So that is t raised to power minus 3 by 2 dt. A raised to m upon n, so m minus n. So 4 minus 3 is 1, so 1 by 2 dt. So you will get t raised to minus 3 by 2 plus 1 upon n plus 1, and here you will have t raised to half plus 1 upon this. So on simplifying, minus 3 plus 2, t raised to minus half upon minus half, t raised to 3 by 2 upon 3 by 2, and you can add plus c, where t is equal to tan x. You can substitute back and you can simplify. So this is a very common problem which is being given in examination, and this is the method in general. So you'll see many type of such questions coming in. Say sin x cos cube x. So here what you will divide with? This particular problem, same as this, 3 by 2 plus 1 by 2. So that is 4 by 2, that is 2. So you will divide by cos square x. So likewise you can get so many problems. This is one of the questions that's based on this, and without root it can be even like this. Say sin x cos cube x. So here you will have to divide by what? Cos to the 3 plus 1, 4. So cos 4x, you will get sec 4x, and denominator you will get tan x. So this particular problem, there is no root, so 1 plus 3, 4, you will divide by cos to the power 4x. Whereas there was a root, so we had to divide by 3 by 2 plus 1 by 2, and here is that. So this all problems are of the same forms, where you need to recognize the form and then solve it, right? We discussed last problem based on sine and cos, which was again direct form. After explanation you can get. Now sometimes let's see how these questions can be put and whether they pertain to this form or not. Now so this is one of the problems I'm talking, dx upon cos cube x root sine 2x. Now last problem we saw that there was only cos and sine. But here if you observe, sin 2x can be written as 2 sin x cos x. Now you see there is only sine and cos, which is in product form. So 1 by root 2 goes out, dx, you have cos cube x. What do you have? Sin x to the power half, cos to the power half, right? Root. So now if you simplify it, you would get sin x, sin raised to power half x, and 3 plus half, cos raised to power 3 plus half, that is 7 by 2x. So 6 plus 1, 7 by 2. Now you see this problem is again of the same form. 7 by 2 plus 1 by 2, that is 8 by 2, that is 4. So you will divide by cos to the power 4x. And what you would get? 1 upon cos to the power 4x. And denominator you have to, sin raised to power half x, and what? Cos raised to power 7 by 2x as it is upon cos to the power 4x. Now you'll see that the way we distribute is, we first try to give whatever powers this can go with it. So from here you have to distribute in such a way that this powers can be distributed so that this cos term. So cos requires 7 by 2, so that is 3.5, and half would go over here. So what we would do is sec to the power 4x. I am writing it like this, sin raised to half upon cos raised to half. So half I have taken out of 4. So once you take half out of 4, you are left with 7 by 2. So that 7 by 2 is distributed to the numerator. So now you can see this would get cancelled, and what would this become? So I am writing numerator as what? Sec square x into sec square x, and sin raised to half cos raised to half, that is nothing but root tan x. So you just need to put, now you can put tan x ko t square also. What help that would give if you put tan x ko t square, sec square x is equal to 2t dt by dx. So what would we get? Sec square x dx is equal to 2t dt, and I would become 1 by root 2. Yes, 1 we need to convert to tan, because second would get converted to this upon root tan x. So now this would go as 2t dt, and what we have substituted, tan x t square. So 1 plus t raised to power 4. Why? Tan square x would be square of this, and this would be 2t dt from here. And what would v be left over here? Here it would be root of t square. So this would get cancelled. So 2 by root 2, 1 plus t raised to power 4 t dt upon t. And then this can be easily integrated. Root 2 comes up, 2 and root 2, rationalize it, or you can cancel it, root 2 into root 2. And what would integral be? 1 dt plus t raised to 4 dt. So root 2 into t plus t raised to power 5 by 5 plus c, and t is equal to what? Root tan x. So now you see this problem was not of a direct form, but we could see convert it in this form and we could solve it like this. So that is one way of doing it. That's the generalized way. Whereas in this particular problem, if you see, we just generalized the concept of this. We broke it into sine and cos, and then the powers got added up. And the same method, 4, so divided by cos to the power 4x, and here we have to distribute accordingly. The best way is you give highest power, all the power of cos, whatever it can take, and remaining would go with sine, or you make sine separate and then give it to cos, so that one goes with tan and the rest becomes whatever is left. So that is how it goes about. But this particular problem can also be, I suppose, solved in a little, not different, but you can say a similar way. If you have a bit command over trigonometry, now see what I can do. I can also write it as 2 tan x upon 1 plus tan square x. Just see. Now what is the use of this? And how do I guess this? See, this guesswork goes with 1 by cos square, which comes x square. So you can particularly write it as 2 tan x upon sec square x. So dx cos cube x into 2 tan x upon sec x. So that becomes, already 1 by cos cube is what? Sec cube. Or let me write it here itself. 1 by cos cube is what? Sec cube x dx. And now we have another sec going up. So sec to the power 4x dx upon this. So now you see, without much effort, I am able to come at this form itself. So without doing much. So that is how it is. This will obviously take lesser time to simplify than that method, but that's a general way. Here you have to see that in this particular form because of sin 2x. Had there been no sin 2x, then this would not have been possible. So that is what we can do it. Then this can be easily solved as the previous problem. From here it reduces to same. Based on previous form, I forgot you can also practice this problem, root tan x sin x cos x. See, usually the books it's solved by putting tan x equal to t square, but you'd get a correct logic why this goes is, once you put root sin root cos, they would reduce to only sin and cos and then the power method. So you should try this problem solving the previous method I discussed. I'll take up one more example of miscellaneous, which is a very common question asked in exam, and it's a good question where students get confused in this. Sin x plus alpha upon sin x minus alpha dx. Now the problem usually when they come in under root creates a lot of problem. You know, with root it's very difficult to take terms out unless we have a square there. It's not like that thing. See, had there been no root, my work would have been easy and I would have been much comfortable looking at this problem. So whenever you have this root or cubic powers, those problems are slightly difficult to handle at student, and especially in exam atmosphere it becomes difficult to strike. But then see, the general principle with root is somewhere at some stage we have to remove the root or the derivative should be available, and trigonometric functions you will not get derivative directly available there. So let us see this problem. See, I'll have to remove root, and especially the root has to be removed from denominator first, numerator the root has to be removed first. So in this particular problem, see, these two are product where angles, which suggests that if I can multiply it by the root of this, say root sin x plus alpha. So this is what the problem is, and I am trying to remove the root. So I am multiplying by this particular way. So what this would help in is, at least I don't have this root appearing. What you will have is sin x plus alpha. And what would you have here? Now here I would have something under the root sin x minus alpha into sin x plus alpha. Now if you see, there is a very common formula, sin a minus b into sin a plus b is what? Sin square a minus sin square b. So if I apply this formula, I would get sin x plus alpha upon under root so till here it's okay. Now how do we go about solving this problem after this stage? So after this stage we need to simplify the numerator as sum and difference. See, that's the basic rule. Numerator should be sum and difference and denominator should be a single term. So what would we get? We would get sin x cos alpha plus cos x sin alpha. And here we have under root sin square x minus sin square alpha. What we have done is we have expanded the numerator using sin a plus b. So that is sin a cos b plus cos a sin b. Now you can see that everything is in terms of sin and cos and denom. So this suggests the substitution can work, because had it been different complicated power, once you have a linear power in numerator, now you can break it as sin x cos alpha upon sin square x minus sin square alpha dx, plus what do we get for the second part? For the second part we get cos x sin alpha upon sin square x minus sin square alpha dx. So now the problem is reduced into two separate integrals, which let us mark as say I1 and I2. We can mark as I1 and I2. Now how do we solve them? Now as far as I2 goes, we have cos x sin alpha and sin square x minus sin square. Say sin square alpha is just like a constant. So you can see that sin square x may be minus 2, half, it cannot be 2 with sin square alpha. Any fraction, the value it can have. So now cos x is here and we have sin. So it suggests us that sin x should be put equal to t. when we put sin x equal to t, what do we get? Cos x dx is equal to dt. So what is I left with? I is left with sin alpha dt, and what you will have here, you will just simply have t square minus sin square alpha. So now you can see that is just a constant, so t square minus a square. Even we would have had sin alpha in the denominator, suppose, then also there would have been no problem. We could have written as a root sin alpha whole square. So now this I1 can be easily integrated or applied as formula. So sorry, I2. So I2 would be what? Sin alpha comes out, and what is the standard form? Dt upon t square minus a square under root, which is log t plus whatever it is there. So that is t square minus sin square alpha. So that would be sin alpha log sin x plus sin square x minus sin square alpha. So that is how we have integrated the first integral. Now we are left with the second part of the, second integral we have done. Now we are left with the first, I1. So how do you go about I1? Now if you see I1, we have sin x cos alpha upon this. Now previous I2, there was sin out here and cos in the numerator we could do, but now both are sin. So logically you should now be able to understand that sin is derivative of which function? Cos x. Do we have cos x? No, but can we get? Yes, we can convert this to cos x. So what would this become? Sin x cos alpha upon, what you will have? 1 minus cos square x minus sin square alpha. So what would this become? This would become sin x cos alpha dx, and children, 1 minus sin square alpha is cos square alpha minus cos square x, right? So after this what we'll get? So we need to find I1, and once we get I1, the problem is solved. What do I do? We put cos x equal to t. So once you put cos x equal to t, the derivative would be minus sin x dx is equal to dt. So what is I1? I1 is equal to minus cos alpha dt, right? And what do we have? Cos square alpha minus, we'll use u, we have already used t, so we'll not use it again. So that is u square. We should use different variables in the same if we are substituting. So this minus cos alpha comes out, this becomes du, and now the form becomes what? Constant first. So under the root you have a squared minus u squared. So what is the formula for that? Sin inverse u by cos alpha. So that is minus cos alpha under root a square minus u square. Sin inverse, what is u? Cos x by cos alpha. So this is the value of I1 and this was the value of I2. So what is I? I is simply I1 plus I2. So you can put this value and this value here, and that will be the required integral, right? So you can see how we proceeded. So there were some differences. We have both sine, then we need to convert one to cos. Otherwise, if both are in a different co-ratio form, then it becomes easy, right? So we discussed about a particular problem, and we have discussed so many trigonometric forms. Now I'll be discussing a question, and after that I'll be discussing a very important question based on that form. Now just saw that sine and sine that way. Now suppose we have a question in which we have to integrate this particular thing. -2. Now, had there been a cosec square x in the numerator, my life would have become easy for integrating it. Why? If you have cosec square x here, I know cosec square x is derivative of what? Cot. And I could have converted 1 plus cot square x here. But here we don't have that cosec square, so that luxury is not with us. So now how do we go about it? There's no cosec square x. So let us see whether sine helps us or not. So we go to sine for help. Let's see what help we can get from sine. Okay, this is something we get. And then, let's see, 1 minus 2 sine squared x upon sine squared x. So now this would go up. So what would become? Sine x. Now, any guesses? Yes? Exactly. Now it reduces to same thing which we had, the both sine and sine. So it's very simple now for me to guess that I need what? To convert this to cos, because we have sine here. Had it been cos, it would have been other way. So this would become sine x, yes, upon 1 minus 2 plus 2 cos square x. So this would again be sine x upon 2 cos square x minus 1 dx, where you put cos x equal to t and proceed. The integration can be done very easily. There will not be any problem. Rest you can do it in standard form. You saw that how we solved a particular type of problem. Now, based on this, we have a very important question quite frequently asked in school examination and was asked in IIT somewhere around, I think, 87. This problem was asked in IIT JEE also. Root cos 2. There are so many methods of solving this problem, but I'll give you a couple of methods. So many means more than one, but we'll discuss a couple of methods. Now, one way is I write it as cos square x minus sine square x. What advantage do we get by this? I suppose nothing as of now. So what does it strike to you? See, once we take this sine inside, I said if you take out sine square it becomes sine, so if you take it would become square. So what would you get? Now if you see this problem, it would be something like this. Sin x would become sine square x, and then it would become cot square x minus 1. Now if you correlate previous problem, see this all are questions which can be created. This can be asked as a question. So how do you go about it? 1 plus cot square x is what? Cosec square x. So cosec square x minus 1 minus 1. Now you see this question we just solved in the denominator. We just solved back. So we just solved this problem. So now we solved for denominator. Let me try to get it there. How? We can rationalize it. So this can be written as cosec square x minus 2 upon cosec square x minus 2 dx. Now you see your I can be broken into two integrals, and luxury I was talking, we'll get in the first integral easily. We have cosec square x, and second integral I have already solved for you in the previous problem. So this will not be discussing at all. We have already integrated this in the previous one. And here, how do you go about it? Cosec square x is derivative of what? Cot. So 1 plus cot square x minus 2. So that is cosec square x upon cot square x minus 1. I've already integrated, so I'm just doing this problem that we have already solved in the last example. So we are not discussing it anymore. So this was the particular problem which was there. Now you can put cot x equal to t for that, and this would imply cosec square x dx is dt. So while solving the second one, you should put u, because we already have used to, and you'll get a minus sign over here. So this becomes, so this particular problem becomes minus dt upon root of t square minus 1, and that is cot x, right, plus what, under root cot square x minus 1, and plus c will put with together. So this we have integrated, this we integrated last time, where we got 2u square minus something, and then you can apply the form. So this is how this particular problem can be solved. But this was not directly, so it's not that easy to guess, and I'll again discuss one more method which we can solve this problem, right? You can copy down this. You just saw how we solved the previous problem using a method. Now I'll discuss some alternative method which you can apply. Now you know this can be written as 1 minus tan square x upon 1 plus tan square x, right, upon sin x dx, using formula for cos 2x. So what does this become? This becomes under root 1 minus tan square x obviously, and a root of sec square x, and you have sin x out here, which again can be written as like this. Obviously, you'll have sec x into sin x dx. Now, after this, what do we do? After this, the problem I, we have taken it will become 1 minus tan square x 1 by cos x into sin x. So this becomes root of 1 minus tan square x upon, tan x dx. Obviously from this stage, if I take tan inside, it would become tan square. So 1 upon tan square is cot square x minus 1. We would reduce to the same thing what we had. Suppose I take this tan inside, tan square would go. So 1 by tan square x is cot square x minus 1. That is. But let me try something different. One concept which we often use while solving problem of integration is that we try to remove the root, and the procedure for removing the root is you put it equal to t square. So we try out that where we don't have any relation, no derivative, so that the root gets eliminated and we proceed. So let me try. Maybe if we put 1 minus tan square equal to t square, what do we get? Minus 2 tan x, right? Sec square x, 2t dt by dx. So this gets cancelled. I don't have anything there, so I'm getting the value of dx as t dt upon tan x sec square x, obviously with a minus sign. Have a look. Now the I which is there, now obviously there is nothing coming as a dx is getting substituted, no values merging. So now when we substitute back, instead of this you can put t square, very good, minus t dt, yes, and yeah, okay, tan x, and we have one more tan x and sec square x. So let us see now what this becomes. What we have substituted, dx we have substituted as minus t dt upon this root t square and tan x as it is. So this would become minus t into t upon tan square x sec square x dt. So this would reduce to minus t square, and then what you would have, tan square x would be how much? What is the value of tan square x? Okay, let me put it like this, tan square x into 1 plus tan square x. Now what is tan square x from here? 1 minus t square, so minus t square upon 1 minus t square into 1 plus 1 minus t square dt. So now you can see this is a very special integral in the form of partial, where you can integrate this. And how do you integrate? You can do that. Take t square equal to y for partial. So this is a very standard form where you can take t square equal to y for partial and go ahead. But I would still suggest that this would be a little longer method. So the previous one is comparatively easier method because here we'll have to still break into partial and go ahead. So I'd suggest to go by that method. So in previous problem you saw we went for two methods, and in that space while I was going with the problem I said there's a question in between a question. So one of the common questions, or again examiner can ask you in miscellaneous, is I'm just discussing a problem this. Now how is it related to the previous problem? Now you would have seen that in between we got cot square x minus 2. So we get cot square x minus 2 or plus 2 doesn't make a difference, it's same. And keep in mind these are co-ratios together. So anything which happens with cot, a method is applicable, it would be applicable with tan also. That's why we have root tan x and we have root cot x. Right? So that is how the things go. So if we can integrate cot square x minus 2, then we can definitely do this. So how do we go? The same method, you rationalize it. So it will become 2 upon root of 2 plus tan square x dx, and here tan square x dx. So this is I. Now to integrate this, what did we do? Convert to sine and cos. So 2 plus sine square x by cos square x, and here you would write it as sec square x minus 1. 1 plus sec square x minus 1 upon under root 2 plus tan square x. So but what we see is we can actually make it more simpler. Instead of we have say 2 out here, seeing this what we can do is 2 plus sec square x minus 1. Let's do that. So it becomes more simpler. We don't have to introduce the sec again. So this will become 1 plus sec square x upon this. Yes. Now it's comparatively simpler to do that. So I becomes dx upon root of 2 plus tan square x and sec square x upon root of 2 plus tan square x. So this can be easily integrated. You just need to put tan x equal to t, sec square x dx becomes dt. For the second integral you can see that tan x equal to t would make that integrable directly. So we don't need to go ahead. Tan x t sec square x dt to 2 plus t square. As far as this first integral is concerned, we can convert this to sine and cos. So this will become 2 plus sine square x by cos square x. And what would that lead to? That would lead to 2 cos square x plus sine square x upon cos square x. Now this cos would definitely go up. The root, when you take a root of cos square x, that would become cos x, and that would go to numerator. And we have cos in the numerator, we should have everything sine in the denominator. So I am writing this cos square as this, because cos is derivative of sine. So here what we are left with? We are left with cos x dx under the root 2 minus 2 sine square x plus sine square x, which is basically equivalent to writing 2 minus sine square x. So just sin x equal to t and cos x dx will be dt. So after we have simplified and come and rest, so it becomes dt upon what? Under root 2 minus t square, that is sine inverse a square minus t square. So what is a square minus t square? Sine inverse t by root 2 plus c. And t is what? Sin x, so that can be. And as far as this was concerned, It's second part, just put tan x equal to u, sec square x dx is du, 2 plus u square. So, and this problem is again similar to what we did under root cot square x minus 2 in between, or you can say integrating 2 plus sec square x and so on. So this is a problem again which is related to the previous one. We have almost discussed so many problems based on trigonometric forms for integration, which I believe is one of the important part in integration, miscellaneous. Algebraic and this, and algebraic have a little different theory. So we'll be discussing, I'll be discussing say, a couple of more questions to wind up the session. So this 1 minus sine 4x. So anything which will be applicable for this is cos also the problem can be solved. And then you can draw inferences for others. That's what you can develop your integration. Based on a problem you should think and try to create problems, whether we can substitute here tan or cot and how does the problem change or what do we get. So that is where you will start, the number of ways you fail, you may be discovering something new. That okay, this works for this and it doesn't work for that. So that's what Thomas Alva Edison said, that it's not that I failed in this many thousand ways, I discovered a new way or another way by which the problem can be done, not by this. Okay, so this is what you can write, and that's cos square x into 1 plus sin square x, and immediately I see there is a sec square x coming here. But there is no tan, so should I introduce? If I try to introduce, I'll have to divide by cos square, so I'll get a sec square, which I can. So cos square and tan square, yes, we can do it. Because you are getting tan and sec here, so otherwise then if you would have had sine or something here, then it would have been problem. So dividing by cos square x, what do we get? What do we get over here? Sec square x into sec square x. Why sec square x into, I am writing it directly, 1 by cos square x. And what would you get here? Sec square x. And what would you get there? Tan square x. So what we have done, we have divided numerator and denominator by cos square x. So sec square x was there, again you divide it by cos square x, you will get one more sec square x. If you divide this by cos square x, you will get sec square x in this. And now you can see that we have sec square in the numerator. So what we should try? We should convert whatever is possible in terms of tan. So this sec square x can be written as 1 plus tan square x. So sec square x into sec square x upon 2 tan square x plus 1 dx. So now they're just left with tan x equal to t, and that would imply sec square x dx equal to dt. So we started off with this, we broke into a square minus b square, so 1 square in this, so 1 minus sin square x into 1 plus sin square x, that's cos square x, and immediately we could see that 1 by cos square is sec square, and hence we went further dividing by cos square x. So now this I becomes what? 1 plus tan square x into sec square x upon 2 tan square x plus 1 dx. So that is nothing but 1 plus t square, obviously dt, upon 2t square plus 1. Now here you have both the degrees same. So what you can do to integrate is either multiply the expression by 2 and divide, so that you get 2t square, 1 by 2, 2t square plus 2 upon 2t square plus 1. So this becomes what? When you break it into 2, 2t square plus 1, or you could have done long division, but it was easy to simplify here mentally itself, so long division is not required, you can directly do it. So this gets cancelled, half integral of dt is t, 2. Again I am taking 2 also common, so dt upon what? T square plus half. 2 is taken out common. So t plus dt upon half t plus 1 upon 1 by root 2 tan inverse. You can simplify and then put it equal to c. So the main job after this is just, so its degree same, or even if degree was more, long division. And if degree is less, obviously partial, but in that case the denominator should be factorizable. So if t cube would have been there, then also we could have done the same method, division, but here the division was not at all required, the factors were pretty, we just required 2t square. So I multiplied by 2 and divided by 2, and then you can substitute where this tt is tan x. So that is how this problem can be solved. Now you saw one more example, and you, by end of this we have seen so many problems where most of the problem you could see one of the major technique was dividing by cos and getting sec square and then going ahead with that. So that is what with practice you draw inferences. I said it's not that just solving a problem we do, it's thinking about it alternatively how we could. In a problem we also showed you 3 or 4 methods. Just to give you an overview that different methods can be applied, there are different ways, and you should think that is what integrating is all about. It's not just focusing on a method, seeing solution in a book and learning that, that's not going to help. It's solving on your own and then thinking about. So the time you spend should be quality time. It's not that you keep practicing and you'll get something. So I'll discuss one more problem, maybe to end up the session, and it's an important problem. And you should see x square plus a square whole square. X square plus a square whole square. Now it goes to x to the power form 4 maybe, and it's an algebraic problem. How do we reduce? See, the substitutions which you learned in inverse trigo would be of help and are of help here, where you can make those substitutions for solving the problem. Now x square plus a square suggests me that I should put x equal to a tan theta. Now let's see how it goes about. So what would be dx? A sec square theta d theta. So what would I reduce to? A sec square theta d theta upon what? A square tan square theta plus a square whole square. So dx, the value has been substituted in this, and x we have taken a tan theta, so x square becomes a square tan square theta. So I is equal to what? A sec square theta, and what is common out here? We have a square, and what is we are left with is tan square theta plus 1 and this. So a square is common. So what is I now? I is a sec square theta d theta and a square sec square theta raised to power whole square. So tan square theta plus 1 is sec square theta a square as it is. So now this you can see it becomes very simple because sec square theta is there in the numerator, that can get cancelled with the denominator counterpart. So 1 sec square gets cancelled, a cube is out, we are just left with sec square theta dt upon sec square theta. And what is 1 by sec square theta? Cos square theta. So 1 by a cube cos square theta d theta. And you know cos square is a very simple integral of what? 1 plus cos 2 theta by 2. To integrate lower powers of cos or sine, we need to break them into lower powers. The higher powers need to be broken down into lower powers till they come to the linear form, right? So now this can be easily integrated. 1 upon a cube, 2 can be taken out, so this becomes d theta simply, and this can be written as cos 2 theta d theta. and both of them are easily integrable. 1 upon 2a cube, the integral of d theta is simply theta, and what you would get for cos 2 theta? The formula is sin 2 theta, and you should keep in mind that you don't confuse with the differentiation formula, whereas for differentiation we have negative coming, so it's integration, so by 2 and plus c. And now what did you substitute? X equal to a tan theta, so we need to get back in that form. And you know this can be converted to tan. How? 2 tan theta upon 1 plus tan square theta plus c. So this 2 gets cancelled. So wherever you have tan theta, you can put x by a, and theta will be tan inverse x by a. So tan theta is what? X by a, and what is theta? Tan inverse x by a. So here wherever you have this theta, you can substitute this, and instead of tan theta, x by a, and you can simplify this. Now in exam, the question which can come on this is a very common question which can come either in this form, which may mislead students at times, or even in a better form they may give you in this form, which students confuse with the lambda form. What is the lambda form of the special integral? You have this x4 plus minus lambda square plus k square. So that is the form I am talking of, where students usually get confused with this particular problem. It's not that easy to guess. So from here you can see that we can go and we can put x code tan theta and solve it. So that is what the inferences you need to draw while integrating and solving the problems. So at the conclusion of the lecture, you have seen that we discussed so many problems involving with trigonometric functions, and you could see that how one concept got related with other and the form was indirect, and in a particular question 2 or 3 methods or forms were applied. But one important point which you should have grasped is that it is the observation and practice which helps you in solving miscellaneous problems. See, for various types of problem there are methods, but for miscellaneous problems there are no particular set of methods. So to develop this skill you need practice, and then you need to draw inferences, and you need to figure out various ways, and you need to create problems where we could do. So as we were seeing that we could do under root 1 plus 2 cot square x, so similarly we can do under root 2 plus tan square x, and the denominator dividing by cos 4x or cos square x. So you need to develop these methods before coming. Miscellaneous problems are not those easy. So instead of studying and practicing for long hours, you should rather try to focus on particular problem, draw conclusions, and then go ahead with the other problem. Don't go for solved problems, too many in books. That will not lead you or help you anywhere. What you need to do is do unsolved, try to correlate inferences, and you should link from one problem to other how it is there. That is where you will be able to develop. Otherwise it's very difficult. See how we got into the cos 6x plus sin 6x. There's a problem which we do putting 1 as sin square x plus cos, and in that particular problem we just cubed it. So that's a new method you could develop. So similarly your practice will help, and you can get back to us with the feedback at the turningpointonline.com. You can send your feedbacks and you can write for problem to us. So I'll just write the web address for you, and as well as, so it is the turning, it's a single letter, the turning point online.com. So there's no gaps in between. You can send us your reviews at this, and you can also get us for the problems, and we'll be posting more lectures as and when in future, and we'll get in touch with you. Thank you very much and have a pleasant time ahead. Thank you.